Welcome back. In this video, I will discuss about the numerical problems of this chapter 1.7, 1.8 and 1.9 and 1.10. Show that the expression Vf is equal to Vi plus At is dimensionally correct. Vi is the velocity, t is equal to 0, A is the acceleration and Vf is the final velocity at time t. So first we will write the dimensions of right hand side like final velocity Vf. We know that velocity has dimensions Lt minus 1. We know from our previous numerical problems knowledge. And right hand side contains Vi plus At. Vi is the initial velocity plus acceleration into t. We write that dimensions of Vi Lt minus 1, then acceleration Lt minus 2, then time having dimensions t enclosed in square brackets. When we will combine both these dimensions, we get 2 times Lt minus 1. 2 has no dimension, so or it's a constant, so we will ignore that. Right hand side is equal to left hand side, so this is dimensionally correct, which is asked in this problem. Next numerical problem is 1.8. The speed v of the sound waves through a medium may be assumed to depend on the density rho of the medium, its modulus of elasticity E, which is the ratio of stress to strain, reduced by the method of dimension the formula for the speed of sound. We have to derive the formula for the speed of sound. We know that speed of sound depends upon density of the medium and modulus of elasticity. We create a relationship between velocity and rho, density, and similarly velocity and modulus of elasticity E. When we combine these both, we have to write it within a constant. A equation has been created having powers rho with A and E with E. B. Dimensions of velocity are Lt minus 1. Density has dimensions ml minus 3. Elastic modulus E has dimensions stress over strain ml minus 1 T minus 2. Dimensions of stress are ml minus 1 T minus 2 as stress is equal to F over A. Strain is a dimensionless, so it is a ratio. Now writing the dimensions of both sides of the equation, Lt minus 1 is equal to m raised to the power a plus bl raised to the power minus 3a minus b and t raised to the power minus 2 times b. Comparing the dimensions on both sides, we get a at level motion. When we will compare these two sides of the equation, we will get a plus b is equal to 0 or a is equal to minus b. Similarly, b is equal to 1 by 2 or half. Substituting the value of a in equation 1, we will get the value of a by substituting the value of this b in equation 2. When we will put the values of a and b, we will get the constants rho की power minus 1 by 2 and e की power 1 by 2. So velocity is equal to constant into e over rho square root, which we have to write in this problem. Next one is 1.9. Show that the famous Einstein's equation E is equal to mc square is dimensionally correct. We know that dimensions of the left hand side of the equation E is equal to ml square t minus 2, because E is equal to energy is equal to work done is equal to F dot D. Dimensions of the right hand side of the equation mc square, where m capital dimension is dimensionally with capital M. C is the speed of light, dimensions Lt minus 2. When we will compare these dimensions, we will see that left hand side dimensions of this equation are equal to right hand side, which we have to find in this numerical problem. So next problem is, so that suppose we are told that the acceleration of the particle moving in a circle of radius r with uniform velocity v is proportional to some power r, say r raised to the power n, and some power v and v raised to the power m. We have to determine the powers of r and v. In order to determine the power of r, we will write radius of circle as given r to the power some n, v raised to the power m. So a is directly proportional to r to the power n and a is directly proportional to v raised to the power m. Combining these, we get a raised directly proportional to the previous. Writing the dimensions of y, lt is equal to constant into l to the power n, as radius is a dimension of having a unit length. Lt minus 1 velocity with raised to the power m. Obey the dimensions of both sides, l raised to the power 1 with l raised to the power n plus m, and t with this on other hand side t. Equation creating powers on both sides, n plus 1 is equal to 1 and m is equal to 2. Putting the value of m in equation 1, we get n is equal to minus 1. So with these values of m and n, we have to find in this problem by creating by creating a formula of equation a acceleration with the powers of r and v. So we have determined the powers of r and v and some power of velocity, and we have checked them with that how these are dimensionally correct. So we have discussed 4 problems in this video: 1.7, 1.8, 1.9 and 1.10. So we have discussed all the numerical problems except this problem 1.5, which is mainly skipped and is not asked in the numerical. So we are done with chapter number 1 with all short questions and numerical problems. In next video, we will start chapter number 2, vectors and equilibrium. We will see its basic concepts and we will start its definitions in the next video. So stay tuned.